Hi everyone, I'm Jaan. Together with me today is my partner Nafiez. Thanks for joining us today on our topic, revisiting software security, state the art. As a disclaimer here today, whatever we said here today is basically our own point of view. So a short intro about us. We are a special interest group located in Malaysia with passion in bug hunting, software security, fuzzing, reverse engineering, and exploits. We call ourselves Tomato Dark Fuzzing Group. You may find some of our notable works in the link below. Next, we have brief agenda of today's topics. Firstly, we will talk in brief the overview of software security. Secondly, we will share about our approach on hunting vulnerabilities, followed by the modern exploitations, and last but not least, our vulnerabilities disclosure. Here is a quick overview of software security. Our talk today will mainly focus on Windows. So throughout the years, we are seeing many reports like following on zero-day being exploited on certain software or programs. Some notable ones like Google Project Zero always disclose new zero-day being used in OS, browser, or PDF, or some documents being exported in the wild. So what makes it fail? In our point of view, it could be due to the third-party software developers or vendors do not follow mitigations techniques built by Microsoft. For example, the compiler options. Besides, there is a lack of secure development lifecycle, which includes software source code auditing and secure coding practice, and also ignorance from developers because they tend to avoid fixes, as also security is very expensive. If the teams isn't capable of software source code auditing, they need to hire third-party auditors to the job and fix the bugs, can delay their development roadmap as well. What's really happening here is Microsoft has improved so many things over the past few years, including killing bugs, classes. This also making fighting vulnerabilities getting super hard and not so straightforward like before. In the other hand, the exploit mitigation on different aspects makes some vulnerabilities become useless. Even if you have a usable vulnerabilities, weaponizing it is very expensive as it takes time to develop and fully working exploit. Next, we will share about our approach on hunting vulnerabilities. Usually, in huntings for bugs, we're going for low-hanging fruits, then to the more complex part. One of our previous works on hunting vulnerabilities in antivirus covering various security issues and methods. The methods used here are almost similar. It just depends on your targets. We do studies others researchers' works and write up. Then we analyze from scratch to understand how it works. Basically, we are trying to reproduce their finding and try to get the same result. We then use that particular case study for different test case on our end. Of course, the easiest way to hunt for vulnerabilities is to have access to the source code itself. However, it is impossible to have access to source code when it comes to closed source software. Thus, this heavily involving reverse engineering. One way to approach this is to fuzz. Fuzzing is hard, but it is fun. In fuzzing, most of our work still rely on traditional methods, such as file format fuzzing, which consists of bytes and bits mutations. We do perform variance huntings like API, functions, and many more. We also do dumb and smart fuzzing as well by using publicly available fuzzer, and also we write our own custom fuzzer. At the moment, our only label on doing the job for us is a Dell PowerEdge server, which equipped with 12 cores and 128 GB of RAM. We split into multiple VM besides on the targets. We usually only run up to 8 VMs concurrently. We do tweak the VM to get better performance. For example, like remove all the fancy visual on OS itself. For the result wise, we pipe out the result to external hard disk for easy access across the members, because we are separate in multiple places. Like Nafiez is currently in Sabah. We do download and prepare corpus on various documents, picture files. So we have collected hundreds of thousands of files in various size. The smallest one will be 1 KB, and the biggest one will up to 30 MB. From our approach on fuzzing, we do get several numbers of CVEs. Our custom built fuzzer on work specific on the selected targets only. We use WinAFL and CERT BFF on fuzzing, as WinAFL support coverage, guided fuzzing, and API. We do use CERT BFF on file format fuzzing with its Python plugins. This is the overall bugs that we found during fuzzing in this year. We do found 4 on Foxit Reader, 12 bugs on WPS Office, 20 bugs on Microsoft Office, 10 bugs on Windows GDI, 8 bugs on Hangom Office, and 30 bugs on Nitro PDF. Our custom fuzzer is still a file format fuzzer, although it's slow, but we happen to use it and found numbers of vulnerability. It do mutation on input files. It's capable on bit flip as well. It's randomly flipping bits, and the range is from 0 to 64 bits. It can cover string and special character as well. We're detecting the crashes via debugger. Yes, although it's very slow, but it works for us. Detecting crashes could trigger false alarm, so we need to split out the result by performing a better filtering. For example, by checking last exceptions like address null or has something on memory or register. Some very important info like access variations, last crashes disassembly code, register value, and stack trace. Sometimes these require manual verifications on our spare time. So this is a result from our custom fuzzer. We do get RC on Microsoft Word, Microsoft Access, WPS Office. Some vendors like Foxit doesn't assign any CVE on the bugs that we submit to them. And we still have a lot more pendings from other vendors as well. So using WinAFL is very effective, but it's very hard to use. It is originally from AFL and is get ported to Windows. It supports instrumentations, and this gives advantage for coverage guided fuzzing, but it doesn't work on all environment. Our test case only work on Windows 10 1511. You can port a custom mutator into WinAFL. We do found some useful vulnerabilities by using WinAFL. Some targets require reverse engineering and code writing, including writing the harness. Ideally, you fuzz on assembly level, you have to extract that disassembly path and turn it into code. If the API available on MSDN, then it's a lot easier for us to write the harness. It is much more faster, however, the input file is only limited maximum to 1 MB. There is minimum resources available online, but you still can get some idea out of it. Following are the result we got from using WinAFL. It's all info leaks bugs in the Windows GDI. Next, we will have CERT BFF. Is able to perform mutation fuzzing on software that consume file input. It is easy to use compared to WinAFL. You just need to configure the Jaan plugin. You can also plug in your own fuzzer engine script as well. For example, using Damsa to call specific parameter to perform mutations. And Damsa will perform this mutation and the result still pipe into BFF for triage. We have very good result from this fuzzer. We do tested out the custom script that we ported and also the default fuzzer script. For our testing, after it's running more than 48 hours, the performance will start slowing down. Thus, our workaround on this is to reboot the VM every 2 to 3 days and restarted the process based on the last executions. It doesn't have limits on file size, but bigger files will slow it down. In some case, it will crash due to several factors such as fail fast and out of memory. Following are the RCE bugs that we reported to Nitro PDF, and we do get some CVE assigned. As per usual, some vendors does not assign any CVE on the bugs that we submitted to them. All right, so next I will pass it to Nafiez.
Hello. So continue on this fuzzing effort that we did for the past years, and based on the fuzzing effort that we had, basically we are trying to write our own exploit as well. Some really success and some really hard to write. And let's go take a look into the modern exploitation. So as steady art, so memory corruption exploitation used to be easy, and in the past we can see like a classical buffer overflow, although it still exists nowadays, but it is really hard to really exploit it. Like we do have many factors that are basically blocking these exploitation techniques, and sometimes it requires a multi-chains of vulnerability in order for us to get a example like a remote code execution or just a simple info leak. And we have seen like historically been exploited for decades. We started to see like a Morris worm where it exploits some buffer overflow issue in the fingered the daemon or the services, and it has been there for many years. And we can see like this year so many like 0 days of Google Chrome and also some Windows kernel being exploited in the wild. And we can see also like the past mitigation not powerful enough to prevent the exploitations. So let's take a look into a vulnerability mitigation that has been done. This was taken from the Microsoft's list of mitigations that they have done since the past. So we can see like a buffer security check, data execution preventions has been there for many years. And we started to see like a null dereference protection where almost every single null is no longer exploitable. And SLR is still there and it's just being improved, like a high entropy. So adding like a bit. So for example, like if you want to like get some address, it might take some time, and also it requires a lot of effort to write those. And also nowadays we see a lot of control flow guard, which is a CFG, and this is one of the painful mitigations that are implemented by Microsoft. Garbage collector, memory garbage collector has been there for, since 4 years ago, 5 years ago, and it mainly focusing on browser itself. So in the past, we do found a vulnerability in a browser like Internet Explorer, and we see a lot of memory garbage collector, which is used in the JIT for protecting the browser itself. And we see a new one like a arbitrary code guard and control integrity guard. So let's back to the past. The Stack Overflow, like this is easy, and we can simply like overflowing stuff, and we get a function pointer, and we can control things and execute whatever that we need. And then we tried, we seen stuff like ASLR being improved, and the attack needs another effort, which is for example, like a code reuse and called return-oriented programming. So it requires a lot of like DLL codes, and we jump from one address to another one. And none of it are like easily guessable like the previous Stack Overflow. So and require a lot of effort on writing the exploits, and then it doesn't even stop at all. Where Microsoft introduced a CFG, where it checks for example, like if there's a call function like a call EAX, they will put some guard there on this, and it calls to the pointer where it will kill the execution itself. And yep, during our fuzzing and vulnerability analysis on one of the program that we fuzz, so this one was found in the HANCOM, the HWP file format program. They don't really implement security on their code, but they're basically relying on allocation program. Like this is during a reverse engineering process, we figure out this is not developed by them, and it's basically by a third party. And yep, we can see that this code is basically trying to protect their program. So we managed to bypass their protection that they're intended to write for their program. So we have submitted a bunch of vulnerability to them and reported that this protection doesn't really fit to their application. So yeah, we do provide a lot of ideas on how they're going to protect instead of relying on one protection. So for example, like we can use like the compiler options. If you use the Visual Studio 2017 and above, there's a lot of new options that can help to prevent exploit or mitigate the exploit. And yep, this is one of the case study that we have exploited. We wanted to show more, but this is one of the easiest exploit that we have written in a modern exploits. So this bug basically is out of bounds read vulnerability, and we found it in a Windows GDI create the bitmap. So so this is basically a function that create a compatible DDB from a DIB and optionally set the bitmaps bits. So yep, how do we found this is basically we found using WinAFL, and And yeah, it took us a couple of minutes, I think only like 20 to 30 minutes to trigger the crash. We written a harness, it's a simple harness. So yeah, basically it triggers memory corruptions during the fuzzing. So we reported this issue to Microsoft with the case number 58593 with the potential exploitation that leads to the info leaks. So during discussion, we have provided as much info as we have, as we couldn't exploit this as in RCE or in another vector. So we figure out that we could abuse this by achieving an info leak. So basically, we could use this vulnerability and exploit it to chain it with multiple bugs. For example, like if we want ASLR bypass, we could use these info leak addresses to bypass ASLR to achieve whatever that we want to multi-chain vulnerability. And yeah, like we mentioned, we couldn't demonstrate the full behavior of the exploitation due to the limitation of the vulnerability. So it requires a multi-chain. So we do have a like an idea, like if we chain with a browser or something like that related to a remote kind of a program, and we could abuse it to gain info leak. So according to Microsoft, it is due by design, so there are no fix for this. And yep, so basically the vulnerability itself is an invalid pointer read, and where the function was found to try to copy specially crafted bitmap data. So as we mentioned, the API itself is basically setting a bitmap bib, so we could manipulate from there and try to achieve an invalid read on the function itself. And yep, as we want to have a solid findings to provide to vendor, right? We usually will write a big or huge POC for them. So yep, we only achieved info leak here. And yep, let's take a look into this crash triage. The first screenshot you see is the one where it triggers access violations, which is triggered on the mem copy. So our harness basically able to trigger to that particular code. And yep, you can see it copies from the ESI to EDI. And yep, when we do some back tracing on the mem copy, where is it called from? We figure out that it was called by the create bitmap and the one that we called in our harness itself. So yeah, when we triage the crashes, right, usually we will do a deep bug analysis. So we spend hours of time to figure out what is actually happening here. So basically, the fault argument of the function itself, if you see in the create bitmap, is basically passing a pointer to an array of uninitialized data, which later pass as source for memcopy to an allocated heap of fixed size. So, so the culprit here, we can see the 6F6D67AE is basically containing an invalid value, the question mark if you seen on the big screen. And yep, so how does it happen, right? So we take a look into a quick overview on it. So before reaching to that part where the input is copied, there is basically a check to test if the third bit of the pointer address is set or not. So if you look at the disassembly code, there's the check that is basically trying to check if it is a bit of the pointer address was set or not. So to conclude the bug analysis, we figure out that the create bitmap copies an initialized data to the allocated heap of size, which is at 0x200, and then triggers the invalid pointer read error. And with this information, we could achieve info leak. So we couldn't find any attack vector because usually the out of bounds rate just like a copying like 1 byte, and it doesn't even sufficient enough to perform another attack vector like RCE or other stuff. So info leak is one of the way. That's why we managed to get one this exploit works from our side. This is the exploitation part. So in order to achieve an info leak, so CBM init must be set to the system. Will use the data pointed by the default argument. So because we are going to spray it with the index of the color table data. So if you see the coloring on the DDESP down there is basically the index color of what we're trying to write on. So the heap allocation also must be large enough to make sure the mask pointer still points to our spray data. So in order for us to get a stable exploit to work, so we need to have a large enough allocation of heap. So this is an example of a proof of concept that we written to and we provided to Microsoft. So we try to set a large size of allocation, and then we try to set the leak stack address as well, and also we need to basically control the spraying indices so that we don't blown the RTL allocate heap. So if we blown that thing, it won't be a useful exploit. So yeah, looking at the modern exploitation or modern vulnerability, we call it. It's basically hard and in the past when we see like a mem copy, we know it's easy to exploit and we can override something on this on the like a register or the memory or wherever that we can store things. So nowadays we see like out of bounds is basically really being handled by the Microsoft program itself, like the memory management and a lot of improvement being done to mitigate or to reduce the attack surface on the vulnerability. So we do have found numbers of issues as well and reported to them, and it doesn't sufficient enough for them to fix the issue because the exploitation doesn't really exist there. So we do provide them info and they help us to write a POC as well to provide the feedback to us back and doesn't even show that the issue is basically can be exploited. So yeah, a lot of looks nice vulnerability, but when it comes to exploitation, it doesn't even give full promises. So yeah. And yeah, to achieve a powerful exploitation, one has to be chained to multiple vulnerabilities. So one vulnerability itself doesn't sufficient enough. So for example, in our case, it doesn't even bring so much attention. Or it's like not useful bugs. And of course, we can see the cost of exploit development will continue to grow and yeah, we can tell like issues like Zerodium and those selling bugs kind of boutique is basically increasing the price and so on. So and a lot of vendors like that are basically trying to fight each other like the pricing and so on. And yeah. So yep, that's about our modern exploitation. So let's take a look into vulnerability disclosure. So yep, this topic has been debated for many years and still ongoing for some cases, and for some countries, they already have the firm disclosures kind of processes. And of course, some people like it, like the higher management people, they tend to send a product to customers and so on, right? And when someone reported a bug, they feel like, hey, this is not good, and you are breaking our product and so on. And like if like EULA or GDPR or whatever that can stop whatever what we call this. Preventing researchers from reporting whatever issues found in the product. So yeah, and of course it's a painful process as well. We do found a couple of vendors that are really hard to work with, and like you need to send like 10 emails. They will reply like one line of email, and they tend to not to entertain researchers. So yeah. And of course, most vendors these days can with a vulnerability disclosure process. So for example, like a Microsoft, Google, and many others vendors. And yep, if you are providing a lot of info, usually they will be more good to you. So yeah, so assuming that you submitting a bug to them, make sure just to make sure to provide as much info as you can, because initially when we submitting a bug to vendors, the large tech vendors, we will get rejected like a couple of times, and not until we get a proper way to write a report or processes or emails or wordings, something like that, so that it's like to make them want to read whatever that you provided to them or reported to them. And yeah, of course, usually vendors gives a feedback. So when we do fuzzing on a Microsoft program, right, they usually give us a feedback like try to look into those specific functions and so on. So try to look deeper on the particular part, because they want us to like helping them to protect their program as well. So they give a feedback to us like how to do it and where to look for. So it's a good idea to have this kind of so that you got both way party to work on. And of course you gotta appreciate the work, and they will give you like CVs or bounties and a lot of things. So and in some cases, like we spoken to vendors, they don't really have a proper channel to disclose vulnerability. So for example, like they don't really have a PGP. So so you are sending like a sensitive information over the email, for example, like a public email, like a Gmail, and yeah, it's I mean like a not proper. So when we ask the vendors like what is the security channel that we can contact with, like an email, or is there any PGP required? Even some of the security team from that vendor, but they don't really have a PGP, so you just submit in a plain text and that's all. So yeah, so you can see like the practices from there is already like giving them a loophole. So that's why they have this uh, dodgy product, so that shifts to the customer. So yeah. And yeah, the vulnerability disclosure sometimes delay in response, and sometimes silent fixes has been shipped to customers. So you gotta like wait for months and asking them in email or any other follow up, like a medium, like a Twitter and so on. And after a couple of months, they suddenly came back to you like, hey, we already shipped this to customer, and you are like, what is happening here? Why no advisory? Or so they said they have an internal advisory for their own customer, but when we ask them and we ask some other folks that if there's a really other internal whatever advisory, and they really don't have, it's just shipping a new update. So yeah, so yeah, these are the issues that are always being like in a vendor. So if they don't really want their program looks bad, going to the news and so on. So when disclosing a vulnerability to vendors, right? So these are the tools that these are our own perspective, our own view. So when disclosing a vulnerability, try to provide as much info. So this will give them an idea, and also try to give them like how to remediate or mitigate the issue, and what like you guiding them the how to fix this, so that they don't introduce another vulnerability. Because we in the past, when we do security testing or finding a vulnerability in a antivirus product, like one of the AV product that we break their AV engine scanner, which allow us to have a RCE, and they fix and ship the fix to the customer, and they ask us to try if the issue has been remediated. So when we look into the program again, we do a simple fuzz on that program. We basically still can do some denial of service, and when we look deeper into the vulnerability, we can actually gain again remote code execution from the program. So yeah. So yep, when we're trying to provide info, just to make sure that they really do the fix. And you can use all the medium for contact, like a social media or general email. So so for some company, then they don't have a security email or mailing list that you can contact with. So what you do, you just send spam, not really spam, but send an email in a proper way, and yeah, and try not to use anonymous name and so on. But if you want to do some disclosure, full disclosure, that's where you want to go anonymous. And of course, reach out to people or researchers out there if you need help, because some people that they don't get entertained by the vendors, so you can help the others to contact or liaise with the vendors, and of course get CERT involved in case if it is a really urgent matter. So this is the don'ts you need to avoid. Just never disclose anything, and not until things settle, because we never know that if you don't work for a large corporation, right? You never know what is happening, so it impacts every single persons or whatever. So yeah, unless you are people from the underground or whatever, then that's your problem. But this advice from us: just never disclose anything, not until those things are being fixed or whatever. That's why we advise to get CERTs involved, or whatever party that really can help you to settle the things down. And yep, most vendors are really corporate these days. Even they're slow, but you need to push, and yeah, and you need to follow up with them. And yeah, of course, although it's time consuming, because everyone is like have their 9-to-5 job, but yeah, you can always like spam them like, what is the due for this and so on. And of course, before you post anything, make sure to inform vendor and get their opinion. So usually when we write about the issue to our blog, usually we'll inform the vendors what to do, and what to write on, and what to include and what not to include. So they will give advice as well. For example, like Microsoft, they will ask us if we are going to provide a proof of concept, a full working exploit, and so on. So usually we'll tell don't, because it might be used by others, attacker or threat actors out there. So yeah, and of course seek for advice for that. So yep, speaking about the vulnerability disclosure in Malaysia, so this is our own opinion as well. So, and yeah, disclosing vulnerability to vendor in Malaysia is pain, regardless of what vendors, or it's still a pain process. When you send one email, they just try to not taking care about it, like I don't mind about this and so on. So and they're trying to avoid those, and they don't just care about their security, and security is not their priority, because their priority is their product or whatever that they're trying to deliver to customer. And of course, we see in a lot of cases, basically vendor trying to sue your researchers, and yeah, and from this we can tell that the company or the vendors itself has a poor vulnerability management, remediation, and security response processes. So they don't really actually have all of this, to be honest, because we have facing one of the cases that related to a security product. We'll talk about it later. So, and of course, no one knows you because you don't have name, and of course, in our culture here in Malaysia, if you don't have name, this is one of the problem that I noticed, that no one will care about you. Like you pause it, like it's like going from the right ear to the left ear, so like it's like nothing happened. And why we spoke about this, like one of our case, we send numbers of emails, and they don't really bother us. So not until the government agency involved in this matter, that's where we seen what is happening. So we'll talk about it later. And of course, vendors usually think that they do better than you, because as a developer, they don't want their program like to be breakable and so on. So yeah, of course, even from our side also, like a security point of view, we want to see things as secure and so on. So yeah, and also now it's 2020, right? So security should be prioritized. So, but yeah, we seen a lot of companies or vendors are trying to moving towards that. And we can see a real world example by one of my friend, the blog that on the link. So you can see the reality of a responsible vulnerability disclosure that's happening to himself. So he got facing a pain process when they're trying to reporting a vulnerability. So yep, this is the case study which is affecting the chiral labs, and this chiral lab or the chiral security lab is basically build one of the first I think antivirus in Malaysia. It's a local product. So the overview of this, we started to look into the product somewhere in end of 2018. It took us a total 5 days to find 12 vulnerabilities with severity from informational to critical. So our first email to them on January 2nd, and they're responding to this after. The conversation didn't work well, not until May 2nd, 2019. Nothing works, and we were almost looking for another alternative to do a full disclosure. And yep, let's take a look into the timeline of a disclosure. Okay, so this is the timeline of the disclosure. It's almost a year. Conversation over the email, over the video discussion, face-to-face meeting, but none of it really worked. So before we go this, let's take a look at a demo. And yep, so this is still from the latest product from their website. We still figure out that this is still vulnerable, which is a local privilege escalation targeting on their KYR. If you see kyrdl.sys, which is a driver that we managed to exploit and gain a system access. So yep, the KISS GUI is basically their interface, and the interface is basically working with the driver itself. And yep, the driver is run as an NT and allows us. So this basically we have written a blog about the vulnerability. What we didn't provide any exploit to the public. So if you can see the command prompt here with a low privilege access, and yep, we're trying to run the poc.exe later and try to exploit, and it will spawn a CMD with a system. So basically the product itself are still like vulnerable. And yep, you can see the spawning cmd.exe there, and yep, we try to see, yeah, and we got the anti-authority system on this program. So basically, the product itself is still vulnerable with whatever that we have reported last year. And looking at the timeline, right? Why I mentioned earlier in the first in the couple of slides back, the pen process is here. Like it took almost a year to figure out to fix things and so on. And January to April is nothing there. It's like they even promised to us that they will ship a new product on April. So not until then that they told us like that we couldn't provide anything to customers and so on. And yep, on May itself, we have a meeting with NACSA, the NC4, the government agency, and we presented the vulnerabilities to them. Initially, we provide them one vulnerability to see how these vendors and the agencies are responding. So they are responding very well, especially NACSA. So they, after the conversation, after the first video conference, the case was coordinated by NACSA, and they're the one who brought this issue to the vendor itself. So from our side, we just follow up whatever that we can, but the enforcement was done by the NACSA itself. And of course, we seek for update again from the NACSA, and they told us that they follow up with the vendor via call, email, and they're trying so many mediums, even using a phone call. So, but none of it responded. And on June 28th, we were invited again to for the video conference with the vendor. And yep, this round they told us like we presented them with 12 vulnerabilities. It's a surprise for them because we want to see how they're going to respond to it. So, and yet they said they will look into the higher severity. Then of course we agree with it. And yep, on the August itself, we got our paper accepted in the Power of Community, or the POC Seoul Security Conference, and one of at that time we about to present hunting vulnerability in antivirus product, which is affecting almost 30 antivirus around the globe, and one of it was a Chiral, which is included in our list. And we informed vendor and NACSA, of course, that we'll be discussing this to public, and we were told by them during in August that they will be releasing a new product in November. So that makes us a bit happy, because we don't have to worry like whoever used the product, they will get the fix by November. So yeah. In October, NACSA sent us an invite, which is a face-to-face meeting on November 1st. And during that face-to-face meeting, me and my buddy, went to the NACSA office. And yes, it's funny when we face-to-face with the vendor, where they told us like we couldn't deliver the ship and the fixed and ship to the customer, or whatever new product that they have, and they told us like they have an issue with the developer and so on. But it's November, right? So they have been promising since January, which is on April, and then like so many Tai Chi here and that, and yeah, and at the end they couldn't fix the issue. So we were told that during either August, or I can't remember which one, but they told us that it took them a lot of time to figure out which vulnerability, how to fix it, and so on. So because in our report we provide them a guide on which part need to be fixed, and we ourselves offer the vendor to review their product once it's shipped, but yeah, they didn't manage. So yeah, we told NACSA we'll be disclosing this to public on the same week of November, during that time, where in South Korea. So we told them like the impact and so on. It couldn't be like it won't be like us only finding this vulnerability. Might be someone else out there and has been used in the wild, exploited, and so on, because the product itself is the name of the product itself is already like outdated since 2015 now, and that time is 2019. 4 years is like imagine like the people exploiting it and so on, because although it looks like only in Malaysia product used, right? But if we see like a nation state sponsor exploitation, APT, whatever involved, the software that they try to attack is not really like a Microsoft or Google or whatever. It's a software like, for example, like a Pakistan APT a couple of years ago. The target product which is unknown to anyone out there. So it's like when you read the report from the Intel report out there, it looks like it's a small product, but it's used by some agencies, and they use that for targets for their target, and exploit the product and gain some whatever that they want. So yeah, so we told this to NACSA that this could impact them. So and yeah, and NACSA agree with our decision, and they required the vendor to fix the issue, no matter any constraint that they're facing. And yep, and of course, disclosing of vulnerability in Malaysia nowadays, we see like NACSA and MICERT are slowly getting better at it. So if you do found a vulnerability, report it to NACSA or MICERT, and of course, if it is affecting the CNII, critical national infrastructure, it will be prioritized by them. So the reason why we reported to NACSA on the Chiral security issue is because of related to the CNII. And of course, if you work with NACSA, we can ensure that they will drive the process and help you to hide your profile. don't publish to public, not until things get settled with the agencies. So let them drive the things. And of course, if you need help to work closely with them, or if you shy, or if you scared that you'll get sued or whatever, you can always seek help up to us, and we'll help you to coordinate alliance with them. As a conclusion, so best defense is offense, and we help the community to eliminate vulnerabilities and engage with vendors for bugs fixing, and we learn a lot of things also, what their processes looks like. And our future focus is in plan as well, fuzzing hypervisor and custom fuzzer with chilling. And if you need anything, you can feel free to ping us at Twitter, and we are open for the local, because we are a special interest group for new blood to join us on this journey. So learning curve for everyone, and as well, we are still in the learning process as well. And thank you, and stay safe. So, all right. Okay, so looks like there's a question. Is chiral software actually being used widely in Malaysia? Oh yeah, it is. It's used in a government agency. So in the past, in their Facebook, they used to post whichever agency they install. What do you call this? For example, if they go for this government agency, they install the product, they will take a picture of it, and they will tell which agency are using it. So from because me and Jaan are from the threat intel background as well, and we do use this as a highlight this as a issue for them, because it will expose whoever use it, because you are vulnerable, you're already vulnerable for many years, and you tell who's the customer is, and it's easy for them to target which one is their target. So yep, it is widely used, but for as what we know is on the government agency. When testing purpose means if I found vulnerability on government website, shall I seek NACSA for this? Yeah, you can seek for NACSA. There's a form, or you can send an email directly to them. If you feel shy to report, or if you need help, you can just liaise to us, and we'll help you to. And of course, they will help you to hide the profile as well. And yep, things that you can avoid, like maybe they will bring you for a conference call and so on. So you need to explain to them what is happening, and what can be remediated, and provide them. So it's like a win-win situation. You give them whatever that needs to be fixed and so on. So yeah,